All right, today we're going to talk about sequences. And what are sequences? Basically, a sequence is just a ordered list of numbers. So to give you a simple example, we start off with a brace. We'll start with 1, will be the first number in the sequence, and then let's say I just add 2 every time. So if I add 2 to that, I get 3. If I add 2 to that, I get 5. If I add 2 to that, I get 7. And if it goes on forever, then you just add a dot, 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 3 dots at the end, close with another brace. All right, so that's basically one type of sequence. This sequence, as you can see, we're just adding 2. When you add the same number every time, this one actually has a name. This is called an arithmetic sequence. If you multiply by the same number every time, it would be a geometric sequence. So an example of a geometric sequence would be, let's say we start with 1 again, but instead of adding 2 every time, let's say we multiply by 2 every time. So if I multiply that by 2, I get 2. And if I multiply that by 2, I get 4. If I multiply that by 2, I get 8. And if it goes on forever, dot, dot, dot. And that's geometric. All right. So these also, let's go ahead and write infinite beside these. And same with this one, ditto. All right. I'm going to give you another sequence, and all I want you to do is I want you to find the missing terms, right? So let's say I've got 3, 7, 11, 15, blank, blank. So go ahead and pause the video and write this down, which I've written so far, and fill in those 2 blanks. You can do that now. All right. So let's see what's going on in the sequence. Well, first thing we do is we look for differences. The difference between these two, 7 minus 3 is 4. So we added 4 to get 3. Added 4 to 3 to get 7. We add 4 to 7 to get 11, right? 11 minus 7 is 4 as well. And then we add 4 to 11 to get 15. So that's the pattern. We're just adding 4 every time. Since we're adding the same number every time, this is also an arithmetic sequence. So if we add 4 to this one, we get 19. If we add 4 to that, we get 23. And that is the 2 missing terms. If I put these in braces, I can call this a finite sequence. Finite sequence. Finite meaning it doesn't go on forever. All right. The position of the number in the sequence, the position is denoted by where it is in the sequence. So for instance, this is the first number, the second number, the third number, the fourth number, and the fifth number, and the sixth number. Usually we use a lowercase letter to denote the function notation for the sequence. So for instance, for this same sequence, we might say a sub 1 is 3, a sub 2 is 7, a sub 3 is 11, a sub 4 is 15, a sub 5 is 19, and a sub 6 is 23. Right. Now it doesn't have to be A, it might be a B, it might be a U. I think in some of our textbooks they actually use a U. This 1 right here is called a subscript. It's not A times 6, it's just saying A with a little bitty 6 to say that this is the 6th number in the sequence. All right, each sequence also has a rule. So for the rule for this sequence, there's two kinds. There's something called the explicit rule. Explicit rule. The explicit rule basically allows you to find any number in the sequence from the rule. If you know the position of the number, you should be able to find it with the explicit rule. It works something like this. If I want to know the nth number in the sequence, so I'm going to use a sub n here. So the nth number in the sequence, how do you find it? Well, basically you have to start with 3. And what do? Well, we always add 4. So I'm going to add 4. And how many times am I going to add 4? Well, I'm going to add 4 n minus 1 times. Let me explain that a little bit. For instance, if I wanted to know the 4th number in the sequence, I would start with 3, and then I'd have to add 4 how many times? Well, I add 4 once, twice, 3 times. So to get to the 4th number, I add 4 3 times. To get to the 6th number, I would add 4 5 times. So starting here, add 4 gives you this one, add 4 twice gives you this, add 4 3 times, add 4 4 times, add 4 5 times gives you 23, right? So let's see if this works. Let's say I want a sub 6. Well, according to the rule, it's 3 plus 4 times n, which I just said was 6, minus 1. All right, let's just work this out. Order of operations says I got to do what's in the parentheses, so 6 minus 1 is 5. Then I have to do the multiplication, so that's 3 plus 20, so that's 23. And that works out, doesn't it? So that's called the explicit rule. There's something also called recursive rule. Not quite as useful as far as finding a number in the sequence, but recursive rules, the idea of a recursive rule is used quite a bit in like computer programming. If you're writing a program and you want to, iterate over a certain number of times, you want to do something, this comes in. This notation will actually come in handy for that. So for the recursive rule, you actually have 2 parts. You have to tell the person where to start. So we say, well, the first number is 3. All right, then to get the nth number, we basically just tell what you have to do to the number right before that number to get it. So if I want the nth number, what do you have to do to the n minus 1th number to get the nth number? Well, you add 4 to it. So let me explain with an example here. Let's say I want the 6th number. The recursive rule says, if you know the 5th number, I'll give you the 6th number. It's saying basically, if you know the 5th number, just add 4 to it, and that'll give you the 6th number. It's sort of like saying, to get the next number, take the number you have now and add 4 to it. So the now is the n minus 1, and the next is the n. Right? So that is the recursive rule. Does it work? We can check it. But in order to check it, you have to step up from 1. So basically, let's say I want to know the 2nd number. Well, I'm going to replace n with 2. So a sub 2 equals a sub n minus 1. Remember, n is 2, so that's 2 minus 1 plus 4. What does that mean? Well, to simplify it a little bit, a sub 2 equals 2 minus 1, a sub 1 plus 4. So it's saying, if you want a sub 2, take a sub 1 and add 4 to it. Well, what is a sub 1? Well, it's right there, it's 3. So a sub 2 is 3 plus 4, which is 7, and as you can see over here, that is correct. So this is the recursive rule for this particular sequence, and this is the explicit rule. All right, so I'm going to give you a sequence similar to number 2. What I want you to do is find the two missing numbers and then find the two rules. I want you to pause it after I write it and see if you can find it on your own, and then we'll go over it. All right, so let's see. We'll start off with 20, and we'll go down to 18, 16, 14, blank, blank. All right, go ahead and pause the video, find the two missing numbers, and then see if you can give me the rule. All right. So let's see, what should you have gotten? As you can see, it's just going down by 2 every time, so this is another arithmetic sequence. So this one's going to be 12, and this one's going to be 10. What's the explicit rule? Well, the explicit rule says start with 20. What do you do to the 20? Well, you take away 2. How many times do you take away 2? Well, n minus 1 times, right? Remember, this is a 1, this is a 2, this is a 3. If I want the second number, how many times do I take away 2 from the first number? Well, just once. All right, let's check it and see if it works. This is, let's see, A4, A5, A6. So it's always smart to check it and make sure it's working. So if I want the 6th number, I'm going to let n be 6. So this will be 20 minus 2 times 6 minus 1. So let's work that out. That's 20 minus 2 times 5, which is 20 minus 10, which is 10. So a sub 6 is 10, and that works out. So the rule works. All right, what about the recursive rule? If you haven't done the recursive rule, go ahead and pause it and try to do it by yourself. All right, so let's see. Remember, with the recursive rule, there's 2 parts. You have to give the first number, and then you have to give the rule. So it would be A1 is 20, and then A sub n is the number before it, which is A sub n minus 1, and then you take away 2. And that's the rule. All right, let's try another one. Number 3. I'm going to do the same as above. You're going to see if you can figure this out by yourself after I write it down. So you're looking for 3 things: 2 missing numbers, explicit rule, and recursive rule. All right, let's see. 1. -4, -9, -14, blank, blank. All right, go to work. All right, let's see. So let's do the explicit rule first. A sub n equals, the first number is 1. What are we doing here every time? Well, I'm just taking away 5, right? You can see, not sure, just take any number in the sequence. So we'll take -4 and take away the number before it, and I get -5. That should work for all of the numbers. So for instance, if I do the -14 and take away the one right before it, which is -9, I get -5. Or if I start with the -9 and take away the one before it, -4, I get -5, right? So it's always -5. So we start with 1. We're taking away 5. How many times do I take away 5? N minus 1 times. All right. Oh, I forgot to write down what these numbers were. Let's see. Take away 5 from this and you get -19, right? And take away 5 from this and you get -24, I believe. All right, let's see if it works. So that's the first, second, third, fourth, fifth, 6th numbers. So if I want the 6th number, I better get -24. That's going to be 1 minus 5 times, this is the sixth number, so I'll put a 6 in there, just like it is there, minus 1. So that's 1 minus 5 times 5, which is 1 minus 25, which is negative 24. So, it works. What about the recursive rule? Well, give the first number, it's 1, and then the rule. A sub n equals a sub n minus 1. What are we doing to it? We're just taking away 5, and that's done. So that's the recursive rule. And this is the explicit rule. All right. Thanks for watching.